For number 17, we're going to solve this equation. X to the 2/3 power plus x to the 1/3 power minus 6 is equal to 0. Whenever we're trying to solve an equation that the exponent is not equal to 1, so just like this, I have like to the 2/3 power, things like that. The best bet is that we should try to factor this out. And indeed, we can factor this out. And this is how I like to show you guys how to do the factors. Okay? So think about this. What times what will be x to the 2/3 power? Well, the trick is x to the 1/3 times x to the 1/3. When you multiply these two things, you just need to add the exponents. 1/3 plus 1/3 is 2/3. So I can break down x to the 2/3 as x to the 1/3 times x to the 1/3. And then now let's look at 6, well, technically a negative 6. And I have to ask myself, what times what will be negative 6? And I'm going to use positive 3 and negative 2. Let me just put this down, and now let's check this out. I will take x to the 1/3 times negative 2, and that will be negative 2x to the 1/3. I'll take the 3, I'll multiply that with x to the 1/3, I will get positive 3x to the 1/3. And notice that if I combine these two terms together, they have the same exponents. Negative 2 plus 3 is positive 1. So I will just get 1x to the 1/3 power. And you see that they have a positive x to the 1/3 power. That's exactly the same as the one in the middle. So these are the correct combinations that we want. And to read the answer, to read the factor, this is going to be x to the 1/3, x to the 1/3 plus 3, okay, times x to the 1/3 minus 2, and that equals to 0. So you cross multiply to check to see if it's a right combination or not. And then if it is correct, x to the 1/3 plus 3, x to the 1/3 minus 2. You read it across for the factors. Then I will just, you see that we have the first parentheses times the second parentheses equal to 0, like the factors. I will just set the first parentheses, x to the 1/3 plus 3 equals to 0. And the second one is x to the 1/3 minus 2 equals to 0. I will solve this one first. I need to subtract 3 on both sides first. I will get x to the 1/3 equals to negative 3. And then I want to isolate the x. Here I have x to the 1/3. And the way to do that is, I will raise both sides to the 3rd power. Because if I do that, I will have to do 1/3 times 3, which will give me 1. So this side will turn out to be x to the 1st power. But I don't need to write the 1st power down. So I have x by itself like this. That equals to negative 3 to the 3rd power. That means negative 3 times negative 3, which is positive 9. And times another negative 3, which is negative 27. And that's pretty much it for the first part. Now the second part. Add the 2 on both sides. Cancel this out. X to the 1/3 is equal to positive 2. Then once again, raise both sides to the 3rd power. Cancel, well, this like 1/3 times 3 is just 1. So the exponents pretty much cancel each other out. And I get x by itself equals to 2 times 2 times 2, which I get 8. Okay? And when you have cube roots, and the thing is that you don't need to worry about cube roots. This will work. So it doesn't really matter if it's negative or positive, guaranteed to work. When you have square roots, you better check the answers. But when you have like denominator is equal to 3 for the exponents, it's like cube root. Right? That's the secret. Both of these are the answers. Okay, both of these are the answers. That's it.